This video was released 1 day early for my Patreon patrons, link in the description. Hello everybody and welcome to this episode of creating a horror game from scratch. I just had an awful experience where I recorded about an hour of footage and I lost all of it. A noise gate was set up improperly and all of the audio was useless. That being said, it did prompt me to go into OBS and make sure that all of my settings are set up exactly how they should be. So we should be getting crispier audio and crispier video. One last thing to note is because I've already done this, I had to go revert all of my changes, which means I might have missed something. So if something seems slightly different than yours, let me know, and I probably accidentally have already changed it in the first attempt. But long story short, let's do this. Today I'm going to teach you about something that I recently learned about, and the fact that I didn't learn about it before now is really unfortunate, and I want to make sure that you're all aware of it because it's something amazing. We may or may not use it for our project. I might just find a niche reason to use it just so it's here, but it's so important that I wanted to show you. What I'm talking about is something called actor components. An actor component is something that is super modular because you essentially set code in a part that is attachable and untouchable to all actors. That probably sounds a little confusing, so let's just go ahead and do this. I'm in my actors folder and I'm going to create an additional folder and I'm going to call this actor components. But before I continue, do note that this first part, just watch. There's nothing to follow along with as we won't be using this file, but it's a very important lesson. I'm going to right click and I'm going to go up here to a blueprint class. I'm going to go down to an actor component and I'm going to name this AC for actor component, which by the way, I don't know if that's the standard for naming conventions, but that's what I've been doing. So AC for actor component underscore, we'll do like a health system. Let's go ahead and open up the health system for those of you that want to follow along. And you'll see we have our basic overrides, but I'm going to go ahead and just delete those. And within our health system, we're going to need a couple of variables. Let's get current health, and we'll set this to be a float. And then we will also get another variable, and we'll call it max health. We'll set both of these to public so they're easier to access. And we will hit save and compile. So I'm going to go slightly out of order so you can kind of see what we're doing. Right now we have an actor component and we've named it health system. Within this we have current health and max health. If we apply this actor component to literally anything, it will have health. Let me give you an example. I'm going to delete it, so I'm just not going to worry too much about the folder structure. I'm just going to create a random blueprint. I'm going to make it an actor, and I'm going to name it like BP chair. And what I'll do with BP chair is I'm going to add a static mesh, and I'll just call it like SM chair. I'll set the static mesh to the Unreal Engine default chair. I'm going to add a box collision. Right now, I'm not really going to explain why. Just trust me that it will make sense eventually. I'll bring it up just slightly so it's not completely under the floor. And then what I'm going to do is I'm going to add our actor component health system. So I'm just going to type in AC underscore and you'll see there's our actor component health system. Now with the health system selected, you'll see on the right hand side, we made current health and max health public and we can now adjust these values. So what I'm going to do is I'm going to set the chair's max health to 100 and its current health to 100 as well. We're going to hit save and compile. Now we'll head back over to the actor component and add some code that can affect its health. So if you remember, something I taught you guys is anytime a variable changes, you want the blueprint that owns that variable to make the changes and not have another blueprint reach inside of another one and make the adjustments. I learned this is called encapsulation. Who knew I was practicing good coding practices and had no clue, but apparently it is called encapsulation and it's something good that we should follow. I'm going to go ahead and right click and I'm going to create a custom event. This one I will call this take damage. In order for take damage to be run though, we need to have a certain amount of damage coming in. So I'm going to require an input and I'm just going to call it damage amount. I put a space in there. Don't do that. Why did I do that? And then we're going to change the type to a float. We're going to hit save and compile. And what we're going to do is we're going to take our current health. We're going to pull out and we're going to type in the word subtract. We'll subtract the damage amount. And then we'll now set our max health. And then we'll set the current health to the new value after subtracting the damage amount. We'll go ahead and comment that and just say take damage. This is just a random blueprint, guys, so don't judge my commenting too much. But we're going to do another custom event. We're going to call it heal damage. Actually, that doesn't make any sense. I'm going to rename this to just heal. Now we're going to require an input just like the top one, and we're going to call it heal amount. We're going to take the current health, but instead of subtracting, this time we're going to add the heal amount. And then we'll set the current health to the amount after the healing is applied. Comment this, heal. And actually, just so I can show you guys how amazing this is, what I'm going to do is I'm going to expand this comment, and we're just going to go ahead and add a print string so we can see what's happening. What we're going to do is we're going to make the string value the current health. So that way, whenever this runs some code, sorry, this looks like absolute garbage. Actually, look, we have it right here. I don't know why I'm doing that. We'll just do this. This makes so much more sense. So now we have a way to adjust the amount of health that the target has. So I'm going to hit save and we're going to hit compile. And then we're going to move back to the BP chair where I'm going to go into the event graph. I'm going to go ahead and I'm going to right click on the box and I'm going to add an on component begin overlap. I'm going to quickly check that it is us. So cast a first person character. And of course, if it is us, this is the great thing about actor components. We can then just reference it. And what we're going to do is we're going to make this thing take damage whenever we overlap with the box. We'll just say the damage amount of 10. I'm going to hit save and compile. And then what I'm going to do is I'm going to drag this into the world. I'm going to hit play. And now, as you can see, if I get close to it, look at the top left, 90, 80, 70, 60, 50. Now, you might be wondering why this is so important. Why does it matter that we have an actor component when this could easily be added to the BP chair? Well, let's say we have more things that need to take damage. What's something else that we can overlap? Let's overlap our east hallway quadrant. So if we wanted to, we could just now, we already have the health system. All we have to do now is hit add AC underscore. There's our health system. Add it. Let's set the current and max to 100. Save and compile. And then what we're going to do is, so we have on component begin overlap, parent ghost. So what we're going to do is when the cast fails, because obviously if it fails, it's going to be us. What we're going to do is get the health system, take damage. I think you guys are starting to get this. We're going to do 10 damage. Save, add compile, go back, hit play, overlap the quadrant. Oh, we can't fit. Oh, it doesn't matter. Look, now I'm damaging the quadrant. So basically, the reason this actor components are so important is because of how modular they are. Because now, instead of having to edit every single one of these blueprints, instead, if I need to affect my health system, all I have to do is go into the actor component that I'm applying to all the actors that have health. Obviously, for our game, The health system isn't going to work, but I wanted to show you a use case. What I'm going to do now is come up with a niche reason or some crazy reason for our game to implement this so we can continue to practice using it. And now I'll have you follow along. I've thought of the perfect reason for us to use an actor component. Instead of a health system, we're actually going to go up here, which by the way, now's the time to start following along. We're going to go up to blueprint class and we're going to make an actor component. We're going to do AC underscore items. And what we're going to do is we're going to use an actor component. We're going to apply it to the first person character, and it's going to take control of all things items. This will be a little bit of a long explanation and a long implementation, so this might be a 2-part video. And I swear to God, if my recording isn't working correctly this time, I'm going to cry. Anyways, let's go ahead and open up our actor component for items. I'll drag it back over here. I'm going to delete the first overrides, and I'm going to start creating some variables. The first variable is going to be named current item, and I'm going to make this an integer. Then, as weird as this might sound, we're going to create another variable. It's going to be called player inventory. And the weird part is it's going to be an array of integers. I will explain why later. For now, we're just going to trust me on it. I'm going to save and compile. I'm now going to add another variable, and it's going to be called item inventory. Now, as of right now, we cannot create the variable type item inventory. So leave it as an array of integers. Let's create what we need for this and come back. Let's open up our content browser. I'm going to go back to my my overall blueprint folder. I'm going to create an additional folder. I'm going to call this the struct folder, struct, and it's short for structure. Let's open that up. In the structure folder, we're going to right click and we're going to go up to the subcategory blueprints, and you're going to see that there's an item here called structure. These things are super, super cool and kind of complicated, so I'm going to do my best to explain them. Let's go ahead and create one. I'm going to call this struct underscore item. So basically, the good thing about a struct is you set the variable types that you need, and you only need one for any item. That probably sounded complicated, but I promise you it's not. Go ahead and open up the struct. Now you're going to get a screen like this, and you're going to go, oh no, is this what it's supposed to look like? The answer is yes, this is a struct. So the easiest way for me to explain what a struct is basically a struct is a set of variables that are always together. Have you ever seen a World of Warcraft tooltip or a tooltip in any RPG where a weapon has a lot of stats? Actually, you know what? I'll go grab one. A tooltip is a great way to show kind of how a struct works. Basically, this is a set of variables that are always going to be together. It has a name. It has potentially a heroic status. It has whether or not the item is soulbound. It has what slot the item goes in, the type of item, the armor, the stats. You're kind of seeing what I'm saying. It's a set of variables that are always together. So in this case, this item struct is being used as armor. So what we need to do is think of all the potential things that our item might need to be our item. So what I'm thinking for now, and we're probably going to add more later. So by default, you're going to think this is overkill by using a struct, but it lets us add more later. All we're going to add is the static mesh. Because if you remember, the only thing the radio is right now is a static mesh. So for the variable type, I'm just going to type in static mesh, and I'm going to scroll down until I see just static mesh, and I'm going to get an object reference. And on the left-hand side here, I'm literally just going to type in the word, or you know what, SM tool, like that. So now we know we need the static mesh for the tool, and we're going to hit save. And now what we're going to do is we're going to close the struct item. And for item inventory, now what we're going to do is we're going to create, or we're going to use that struct as the array or the type of variable that this array is. So I'm going to type in, wait, what was it? It was struct underscore item. Yes. So it's struct item. And when I hit save and compile on the right hand side, you'll see now we have an array of items. So when we start adding stuff, you'll see that whenever we hit this little caret, we now can assign a static mesh to this item in the array. So our first item, I'm actually going to leave as nothing because that'll be if our hands are empty. I'm going to add another one, and the other one is now going to be radio. Oh, or not radio, it's walkie, isn't it? There we go. So item 1, our hands. Item 2, the walkie. Let's go ahead and hit save and compile. Now this is where things are going to get a little bit complicated. We need to create a couple of functions or events that we're going to call in order to update what item is in the player's hand. So let's go ahead and create a custom event, and we're going to call it change item. So whenever we set a hotkey for the player to click, we're going to call change item. What we need to do is look at what their current item is. We also need to know where they're at in their player inventory. If this array is at the end, we need to reset the array so it cycles through their inventory and doesn't go past what their inventory currently has. So in order to do that, we need to take player inventory and we need to get the length of it. Also, here's a neat little tip that I learned. I didn't know if you guys knew. If you select both of these nodes and press Q on the keyboard, it will straighten out any of those jittery lines you might get. Anyway, we need to see if the current item is at the end of the array, but we have the array length. So we want to see if the current item is greater than or equal to the length of their inventory. I'm gonna grab both these, press Q. Obviously you can just see if it's equal, but just in case some funkiness happens, I also like to check in case it went past. We'll need a branch, so we're gonna hold B and click. We're gonna plug our condition in, and then we're gonna plug in this to the branch. So if they are at the end of the array of their inventory, all we need to do is set the current item back to 0. So that way they go back to the beginning of the inventory. If they're not at the end of the inventory, then we simply need to take the current item. We're going to add 1 and then set the current item plus 1. Save and compile. So now what we've done is we've made a very simple system that will cycle through whatever the current length of the player inventory is. Let's go ahead and grab it. We're going to comment, and we're going to make this a decent sized comment. Check if the current item is the last item in the current player's inventory by seeing the length of the array. If they're at the end, then we cycle back through the inventory by setting the current item to 0, which of course is the first item in an array. Smiley face. Per usual, I don't like the default color, so I'm gonna come over here and just set the comment color to white for now. So now we need to actually set the item. So we're going to create a custom event and we're going to do set item. We changed it. Now we're going to set it. For our set item, we're actually going to require an input. We need the current item. So here's the thing. I'm going to go ahead and just type it in like this, and I'm going to change it to an integer. Now, there's 2 ways you could do this. You could absolutely just pull this out and have it sitting here like that. But I'm kind of getting into the habit of, if a function requires input, to just have it required. So that way you'll never have the function called if it like doesn't have the information it needs. It will always have it because it requires it. So now that we have it set here, let's go ahead and let's let this save. Never mind. Let's go ahead and expand this comment. And out of the top one, I'm going to move down to about the middle here. And now we're going to set the item. So we'll hit set item just like that. And here's the thing. This is actually where we're going to plug in the variable of current item. I know that probably sounds weird, but we know current item will 100% be set, because in order to get to this code, it's going to run through 2 different sets for that variable. Basically, I'm just creating a bunch of security and insurance to make sure our code is bulletproof. So this is where things get interesting. In fact, I'm going to open up Paint so I can better explain this. What I'm going to do is create 2 visual representations of our arrays. I'm going to go ahead and create the player inventory array, and I'm going to make it green because we're using integers. And then I'm going to use blue. Oh, it changes that. I haven't used Paint in so long. I got to deselect it first. And then use blue as the inventory, or the item inventory array. So the reason we have to do this convoluted setup is because we don't know the order in which the player might receive items. So we want this to be modular just in case they get them in a different order than we expected. I'm even going to grab the pencil here, and we're just going to say that the current item, which I'll make like this sky blue color, their current item is 2. Their player inventory looks like this. They have 0 because that's their hand. They have 3 because they got items in a weird order, and 6. So this is probably already kind of confusing. If the current item is 2, but the player inventory is set to 0, 3, and 6, what item are they holding? Well, let's run our logic in Paint. Let's see. Their current item is 2, so let's pretend they want to switch items. Well, out of the array, we get the length, which, as you can see in this case, is going to be... In fact, I'm glad I did this, because the length equals 3, which means it's not doing what I want it to do because I didn't account for the fact that this starts at 0. So we already have a small error. If you're not following why this is an error, it's okay. Let's just make the change really quick. Essentially, all we have to do is, when we do this check, we need to add 1 to the current item and then do the check. So I'm going to plug it in like that and then bring this down for some space. Okay. So now it makes sense. Their current item is 2 and the length equals 3. They go to switch their item. Well, because we're dealing with addresses, we went ahead and we added 1 to this, which means that actually this is going to be 3. The length is 3, which means we are going to reset and go back to 0, which means that the current item of 2 is actually 6. Did I confuse you? Well, remember, let's think about this in the form of addresses. This is 0, this is 1, and this is 2. Because this starts at 0, that's actually why we have to add 1 when checking against the length. Because the length starts at 1, whereas the array starts at 0. So whenever the current item is 2, they are holding item number 6. To clarify why this is so complicated and the reason we have to do it this way is, let's say 0. Well, we know 0. 0 is the hands, so I'll just put an H. 3 we'll just pretend is the flashbang, so I'll put an F. And 6 will be the flamethrower, so I put an FL. Now, we didn't know that the player was going to pick these items up in this order. So you might be asking yourself, why does it matter what order they pick them up in? Well, I'm glad you asked. Because we have our item inventory, which is going to stay 100% consistent no matter what. So this is always consistent. So 1, 2, 3, 4, 5, 6, or I probably shouldn't have done that. Let's use their addresses. 0, 1, 2, 3, 4, and 5. So actually here we're gonna add a 6th. Boom, 6. So this is an item, this is an item, this is an item, blah, 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 blah. Well, when a player picks up 0 or has 0, then gets 3, then 6, if we were to just increase the size of the inventory, well, the addresses are 0, 1, and 2. So they wouldn't get items 0, 3, and 6. They'd get items 0, 1, and 2. So we have to have an array of integers that are actually the addresses of the item inventory, so we can apply the appropriate details. If you're dazed and confused, just follow along, and I hope it starts to make sense as we go. So we have the current item. So let's go ahead and get the player inventory. We need to get a copy of the current item. And remember, this code is ran after we've changed the item. So the item has been changed, and that means that this item here is the one we're switching to. So we need to look in our inventory and say, okay, they want to switch to whatever is in address 2, for example. So we pull out whatever number is in address 2, and that number is the address for the item we're getting. So then we go over here, we type in get a copy, we take that address, plug it in, and there we go. So we go to the next item and or cycle back to the beginning. We take whatever item we're on, we see what's in our inventory, which is a list of essentially addresses. We get the address, then we're able to get the item we need. We're going to go ahead and save and compile, and we're going to come back to this in the next video. This is complicated. It's overwhelming, but it's okay. Okay, we're learning really cool stuff. We're going to come back, and we're going to knock this out. Don't forget to like, comment, and subscribe. See you guys in the next video.